Welcome to yet another Smart QA Musings, and today's musing is on structural aspects. So every musing, I think we discuss or we outline different things, and today I thought we'll look at technology and structure. And therefore the title is The Hidden Skeleton of Quality, which is really the silent backbone that sustains assurance. So what are we really talking about? We're really talking about the fact that what we see as systems and what we evaluate as systems more often is from what we see as external behavior. So we stimulate the system, we perturb the system externally, observe the behavior and find issues, make observations, come up with suggestions and so on. But we all know that at the end of the day, what is inside has a significant contribution to the perceived quality of the outside. So what we want to be able to be cognizant about is there is a fantastic skeleton inside, and that skeleton with its bones and tendons and all that stuff is what makes ultimate software robust and makes the experience interesting. So it's really the silent backbone that really sustains the entire system and assures great experience to all the customers. So what I would like to do now is to kind of look at it in two parts, just reflect on a few interesting ideas and what do we really mean by structure, because there is a phrase that we use called the white box, which can more often be mistaken by a lot of people in the industry per se, not necessarily to us. So let's reflect on it to understand what do we mean by saying structural validation, what are the issues that are there, and understand the notion of layers in a structure, and then go a little deeper to examine kinds of issues that are deeper, what kind of probes you might need and so on. And being a 30-minute musing, so the style is in musing, it's certainly not pedagogic. Okay. So we're really looking at the unseen aspects and see how structure plays a vital role to assuring software. So let's get on with a bit of a reflection. When you look at the structure, is it the code structure? Most often when we look at structure, we seem to think of it as structure at the lowest level, which is the internal piece, which is really the technical part, the technology part, which is about local correctness, which could be in the context of code, static versions, context of the code as it runs, the runtime version. But is it all it is? No. Truly, if you look at structure, probably it's like a three-part skeleton. The first one is the central core of the code that we write, and therefore there is a bit of a structure which is lower order structure, right? We'll talk about what they might mean as we go further. The second would be about certain visible pieces that come out as attributes, but they are really more of a systemic behavior, not the local pieces of individual code or module that we write. And we are more often interested in their behavior in specific situations, possibly in terms of load, stress, bandwidth, resource constraints, timing aspects, and so on and so forth. So we kind of are graduating to the next level, higher part, which is to a larger degree the systemic structure. And then of course you really get the higher order part of the skeleton, which is really the overall architecture, where I think we can view the structure not as the individual pieces of code or certain flows and certain behaviors that emanate from certain systemic behavior as part of a flow, but really how it has been put together, the notion of systemic patterns and how they're integrated, what is their notion of resilience, and so on and so forth. So I'm sure when we look at even at patterns today, you have seen code patterns, you've seen architectural patterns. So there are design patterns that exist at the lowest level and go on all the way to higher level, right? And much in the similar fashion, we are looking at the architecture in the same layered kind of a lens. Now, why do we do this? Why could we possibly do this? I think the interesting thing is that each of these lenses at different layers, shows up a different set of fragility, potential fragility, right? And that's what we want to look at. So what we're trying to get to is the notion of skeleton is what we see versus what we hold up. So we kind of looked at the notion of what we see as external pieces, the flows that are smooth, features that are visible, behavior that is external, and more often, therefore, we probe what is really the visible. But ultimate experience is not just what comes from what we see. It is really something that is delivered by the unseen, the skeleton. The skeleton inside, which we saw, was probably 3 parts. And that's what it is. And what do they handle? What do they have to do? So the skeleton has to handle erroneous situations, could be exceptions, interesting or invalid or potentially threatening states, interesting internal life cycles of resources sometimes, the fundamental notion of resilience. All these are what is inside, what holds it up, which we don't see. It's like a scaffolding that is inside. Just for the purpose of picture, as you can see, the scaffolding is on the outside, but what I'm really communicating is there is a fundamental and internal scaffolding, and it's something that we need to certainly validate. So, applications that are more platform-oriented obviously demand a more deeper assurance of the internal skeleton. Applications that are more end-user focused, we more often look at what we see, and therefore we evaluate behaviors from its flows, the features, the external behavior, and so on. But certainly when we test non-functional aspects, the internal pieces, as we all know, emanate. They are key to ensuring that the attributes are met, and therefore it allows us to have a great experience with the system. So when we look at in slightly more detail as to what these layers could mean and what they could possibly help us, if you look at the most internal skeleton, the technical layer, which is really about local correctness, where we're talking about structural issues from the aspect of code that we write. So what does that mean? It could mean some of these. It could mean how we handle exceptions. Do we swallow it? Do we appropriately handle it? Do we just discard it and then I wouldn't say discard it. Do we actually emanate it all the way and ultimately show up an error message which actually is useless to the customer or the end user? So I guess those are ideas that are more technical layer, local correctness. If you had a system that was multi-threaded, then you would have possible issues of synchronization, possible issues of race conditions, possible deadlocks, and therefore resulting in higher unpredictable behavior. So that's another example of a structural issue. Or when we have a set of activities which result in a transaction, the notion of a transaction failing, not being able to roll back, maybe resulting in certain records which are orphans, could be a visible aspect of structural issue in the data side. And the other one, which some of us are probably very aware of, is the notion of leakage. Resource leaking. Could be any kind of resource, memory being one of the more common ones that we look at, but there could be other resources too. Could be handles, could be OS resources, which ultimately leaks, and in the entire process it consumes, and therefore results in more often a fatal issue, which could be like a crash. So some of these issues which we see are more at the innermost level. That is something that we as developers possibly take cognizance of, hopefully take care of it as part of our structural testing, hopefully as part of the unit test, so to speak, or dev test, so to speak. So this is one, the innermost skeleton and its potential weak points, not necessarily all of it, probably some of the key ones that matter. If I go on to the next layer and look at it from an attribute, those that become visible as attributes, the attributes as in terms of time, like performance, attributes as in terms of security, attributes as in terms of failures and reliability, and so on and so forth, handling of stress, and so on and so forth. Now, they are not just a result of our piece of code. It is more often the way certain things have been bolted together, and therefore there is a notion of a systemic pattern, and they result in potential structural fragilities. Like what? Failovers not being done, holes of security that possibly results in leaking of data, limits that happen because of scalability, like thread pools exhausting, and therefore system doesn't scale. Bottlenecks happen because we probably didn't design certain aspects well enough or didn't connect it. So suddenly there are pieces where suddenly the flow gets into a bit of a bottleneck, which probably results in latency times increasing, and therefore you get a long tail. So these are not just the result of me as a programmer, it's we as a collective, which results in structural fragilities, which is also an aspect of structural quality, which is the part 2 of that skeleton, so to speak. And finally, when you look at it from a systemic notion, which is at the highest order of an architecture, we are really talking about the behavior in various situations. Could be incoherence as in terms of certain states or certain caches, so we get stale data, we get into wrong states, we get into states that we can't come out. We get into a situation where it's a transactional system. It is not necessary, it's an asynchronous and transactional system, so you end up having certain messaging issues. Could be failures, could be duplicate messages, could be lost messages, and so on and so forth. Or it could be a leaky boundary. That means whenever there are interfaces, there are certain leaks that happen and contracts that are not enforced, and therefore those cause issues. And these are really higher order decisions that we make at an architecture layer. So when we are really looking at structural quality, we are not just talking about code coverage or memory leaks at the innermost level. All these are probably important. And all of these may not be necessarily easy to validate at the end, but some of them require probably a much more cleaner review, discussion, prototyping, experimentation, in addition to validation. Right? So what happens here obviously is at scale, when things at a higher level scale, it's not just because of one issue, it's because of a more systemic kind of a crack. So if you've been following the more recent AI crash that we had in Ahmedabad, whose reason is not yet fully published, not completely known, it was not necessarily like most of the air crashes, a simple one. There are various theories that are going around, and when you look more carefully at variety of data that is available in a public fashion today, it seems to indicate quite obviously a fairly systemic failure of the entire system. So when you say systemic failure, there is a FADEC or a digital control system. Maybe the thing that failed, and when you ask why that failed, well, there are a few reasons that come along. Then it causes electrical issue, then it causes a few other issues. So it's not as much as just a particular simple bug that blew it up, right? And that's why some of these investigations are harder from a technical perspective, and it also may be difficult to know the exact truth because of reasons beyond technical aspects. But the notion of a fragility is at a code level, at a flow level, at a system integration, system architecture level. So maybe you want to take a few seconds and just reflect, what might be skeletons in your systems. Not necessarily it's, that there is some major demon inside every system. It is just that as a smart assurance person, we are always looking at issues from a variety of different angles, and quite naturally we also need to take a look at the internal aspects. So think on these things. It's not about answers that matter here, we're just trying to reflect, and before we go on into the next session of going a little deeper and looking at more details, what do you think are parts of your system that stand unseen but you think are essential? What do you think could be certain silent fractures that could be possibly be forming in your application or your system? The third reflection is, there is a strong backbone that you have, but how do you nurture the backbone before it weakens? And weakening may happen due to very many things. One part is our modification and upgrade. The weakening of backbone may occur because we may use some other layers, some other libraries, systems, components, which also part of the backbone. So it is not necessarily that I am the only culprit. It is me. It is a difference in terms of how people use. It's different, it is the external environments that we consume and use, which could be environments, which could be libraries, could be other systems. So the backbone is not just me alone. So this slide is just to, throw these questions at you and ask you to reflect, hey, hopefully you are aware of what is unseen. You are probably constantly, thinking on some potential fractures that could be silent. And of course, constantly you are sensitive to whatever changes that we make or the environment makes in terms of ensuring that the backbone is not compromised as we go forward. So think on these things. Now let's go a little deeper and look at, in some sense, some of the details of the failures and the issues and the way we might want to look at probing before we wind up. So let's look at possibly the anatomy of some of the structural issues, which is really the innermost piece, the technical slice that we talked about, which is more often something that I, as probably a developer, programmer, end up doing. This is what we talked about. We talked about exceptions, concurrencies, synchronizations, race conditions. We talked about transactions and integrity. So some of those might be some of the key categories, and therefore some of the issues would be like what we briefly alluded to. Exception which are swallowed and not handled properly, or bubbled unnecessarily to. And we also talked about, the races, the deadlocks, partial commits, the notion of idempotency, where you do the same transaction, it changes certain stuff, right? So if you create a new user and keep on doing the same API, create a new user or do a new transaction, then we know that the system is changing constantly because newer users are being added. So its idempotency has to be careful. So what are we trying to look at here? We are trying to look at, here are some category of issues which could describe the anatomy of structural issues at the innermost core, which examples of which are these technical issues. And then we are asking ourselves, what could be the way to probe? And it's not exactly test cases or scenarios, these are ideas for probing. And therefore the last column is really saying, hey, how do I find out some of these? What could be some ideas? And as you can see with respect to exception, force a fault. See if, so which means you are deliberately trying to stimulate those exceptions. So if you say there is a memory not available exception, then the question is, are we able to, should we simulate a condition, force an exception, and see what happens? And that's what we're saying by saying force a runtime fault, check the error contract, check maybe the logs, and so on. So it's an idea. How to implement it is a different part. When it comes to categories of timing, concurrencies, threadings, which may result in races and deadlocks and unsafe shared states, What we're trying to do is idea is to figure out how can I find out what are those aspects that could be highly contended. How do I check the deadlocks? How do I check the races? And you and I know that those are not easily discernible from an external aspect. You have to hypothesize situations. We have to probably mentally run certain things to be able to detect some of those. So it's more often not a dynamic assessment in the timing aspects. It's more often, I would say, static and intellectual. Whereas the notion of transactions and integrity, the idea of probes could be to say, hey, when I'm doing a transaction which may consist of number of operations, so can I kill it midway? And if I kill it midway, how is it? Is it affecting the system? Does it roll back? And so on. Right? So wherever we have large enterprise systems using a lot of data, having a lot of asynchronism, then these become fairly paramount. Certainly in the case of a multi-user system, multi-threaded system, I'm sure you appreciate this a lot more. So this is to kind of give a gist on, how some of the, the structural issues look like and what we might do to possibly uncover them. If I go on to the next notion of the fragilities of the overall structure, which is really in the flow, which is really results in attributes being compromised. And if I pick some of the common, more often attributes that matter, like performance, reliability, security, etc., I'm sure you appreciate some of those tech issues that are outlined as part of the category. Bottlenecks, garbage collector pauses, latencies, reliability as in terms of failover is very weak and slow, reliability compromised because systems are retrying and you get a lot of retries and therefore it's a storm of retries. And so what is a probe? So I think performance is one thing we probably understand far better because we do that more often. We stress the system at higher order loads, maybe 3x, maybe 5x and so on, and we measure 95th percentile, 99th percentile of time. And that's something that we more often conduct as a performance testing, but remember we can also certainly do modeling and do performance engineering. As far as reliability is concerned, well, there is one part of reliability modeling and mathematical determination in terms of failures. The other one is actually test, where we force the latency, check some timeouts, find out if there are retries, find out jitters and stuff like that, and therefore try to see if it is resilient enough. On the context of security, some of those things, I'm sure it's a fairly vast subject by itself. Some of you may be using OWASP and stuff like that. But some of the ideas which are displayed may be replaying expired tokens or rotating the keys and so on and so forth. These are some ideas, right? And there is a whole bunch of it. This is just to give you a sample. So the intention of this particular slide set was to kind of connect the notion of certain categories of issues at each of these parts of the skeleton, some examples of issues that come up at that particular layer, and of course some ideas of how we might want to probe to be able to detect or prevent or preempt some of these issues. Right? Now, the last one is on the architecture, where we talked about the outermost stuff, where we said, at an architecture level, the cracks really cascade through the whole skeleton. So if there's an architectural issue, that's probably going to be the most nasty and probably result in some of the most fatal issues, but they may occur not every day. It might be very infrequent, but it may be very catastrophic. So some of the categories of these cracks at an architecture slice, as you see, is how well we have decomposed services, how well we have taken care of events and eventing and messaging, certain aspects of deployment and release, where, for example, in the context of deployment, you may not roll out the whole application, you might do a canary rollout, which means you roll out a small portion, try it out with a small bunch of users, and then, of course, iron out some issues before you roll it out across the entire production. So you would probably do a bit of a canary or maybe rollback and so on and so forth. Especially important in systems that are fundamentally transactional, fundamentally 24/7, right? So that's in the aspect of deployment and release and some kind of a probe idea here. So when you look at the service decomposition where you're looking at, the interfaces not being so good enough, or there are too many calls that go up and down, which is chatty in nature, or there are shared databases and so on. So what is some probe idea? What could be one such? You can probably kill a service and see what happens. So what does that mean? What does observe blast radius could mean? It just means that, hey, if I have a fair bit of services that accomplish my flow, and it could be possible that a particular service may be called many, many times to accomplish a few things. And let's say that if one of those services go down, and we deliberately make it go down, how does it impact? How far does it ripple back? And that's the idea of a probe here. One example of idea of a probe. When you talk about events and messages, what we're really talking about is probe idea is like, hey, maybe we can inject some duplicates and see how it works. Does it discard? Does it confuse itself? And so on and so forth. Right? So these are some examples of systemic cracks which are categorized in this case, some sampled 3 categories and some ideas of probe, if you will. So before we close down, let's take a quick look in terms of the kind of probes that we are trying to talk about. So are all of them of the same intensity? Not really, because when we look at these probes across these 3 parts of the skeleton or 3 layers of the skeleton, there are some quick probes, lightweight. Like you put some invalid inputs, you probably try some rewrites, retry the writes, maybe we do some multiple concurrent updates, which are comparatively easier. They are lightweight. They can be done in a few minutes. They can be done in a session, right? So the invalid inputs may be resulting in certain finding out if errors have been well handled, the contract of errors, and so on and so on. On the contrary, there could be probes which are deeper, where you might end up doing chaos testing, you might do fault injection, and those are some of the examples that's up there as the 3rd column, where we kind of kill a particular sequence, kill one of those sagas mid-step and see if it rolls back. Maybe we inject certain latency and therefore see what happens to packet loss, and there is a meaning, does it result in meaningfully bounded retries? Or maybe exhaust certain resource pools like database and see how it does graceful recovery. So they are much more deeper. Obviously takes more effort. Obviously need to invest time, and maybe requires some pieces of tools and technology to be able to do it. Right? And therefore when we look at these probes, some of these are easier, simpler, faster, and some of them obviously much more deeper. And if I were to lay it out as a table and conclude this by saying, hey, this is how the map may look like. And if I put those maps as 3 columns representing the inner, the middle, and the outer, that's what it looks like. So this is just there for detail's sake. I certainly am not going to confuse you, or some of which we talked about, right? So we talked about technical or local correctness as in terms of issues related to errors, exception handling, concurrencies, transaction. You could have a little more, right? By the same token, if you go to the next level, we talked about some of them, there could be some more. Maintainability pain like couplings, portability issues, security aspects, and so on and so forth, right? And when we looked at architecture, we talked about a few. There could be some more. There could be APIs and contract threads, which result in not idempotent applications. API and contracts where they are violated, and so on and so on. Right? So, in a nutshell, what I was trying to muse about is to go a little more deeper into the idea that there are skeletons and they have to be strong, they have to be robust, they can never be compromised with changes. What do they look like? It's not as simple as what might be sometimes understood as white box related to code. Structure is something more deeper, and obviously there is inner structure which relates to the code, the outer structure which relates to compositions of code as a flow, and the outermost structure which holds the entire stuff, which really is the architecture. And there are different classes of issues, different probe ideas therefore, and some of them are deeper, some of them are not so deep, and they are quick, and not all of them may be validation oriented. They might be static in nature. Thank you.